All right, everyone, welcome back. So today we are going to be doing 13.2. So if you haven't yet watched 13.1, make sure you go watch that one first because you're not going to know how to do the solving portion of the inequality if you haven't watched that yet. So we're going to take all of the skills that you learned from 13.1 and apply them to real-world problems. Now, I do want to go ahead and put this out there that some of these problems are not necessarily intuitive the first few times that you try them. Okay, you're going to get a hang of it, but it can be a little bit tricky to kind of logic your way around. So I do have a few tips for you as we go through. So step 1, identify the variable. Write the absolute value inequality to represent the given situation. I often will use x as my variable, but you can use something that's more like personalized to the problem. Solve the absolute value inequality and write your answer in context. So Ivan made a personal goal of saving $96 per month. Each month he has been averaging within $8.65 of his goal. So let's talk a little bit about what an absolute value does and its purpose. An absolute value of something finds one's distance from something, okay? One's distance from 0. So if you take the absolute value of a number and you solve it, that's how much of its distance is from 0, okay? So we're trying to find one's distance from something. So if we're talking about within 8.65 of his goal, $8.65 of his goal, that could be less or more, right, within that range. So here's how we're going to set it up. So it's going to be the absolute value of your personal goal, I'm going to call it x, minus 96. So it's always going to be x minus the distance from the goal, okay? So x minus this will tell us my distance from the goal, okay? And our distance from the goal should be less than or equal to 8.65 because our distance from the goal should be either less than or equal to 8.65 because we want it to be within that amount, okay? So I wrote a little note here. If you take the amount saved that month and find its distance from the goal, it should be less than or equal to the average, okay? So this right here is going to kind of help guide you through. So it's always going to be our variable minus the goal is less than or equal to the average that we want it to be within. Okay, that's how we're going to set it up. Now from here, you can solve this absolute value inequality the same way we solved it in today's lesson or yesterday's lesson, however you want to say, 13.1. So I'm going to take the positive version. And I'm going to solve that. You know, I got to grab a calculator because I'm at home and I don't have one, so give me a sec. Okay, calculator is obtained. So we got 8.65 plus 96. That gives me 104.65. And then we're going to have to do the negative version as well, just like we did earlier today. So we have negative 1 times x minus 96 is less than or equal to 8.65. Now remember, you have the option of dividing by the negative 1 right away or distributing it. Whatever you feel most comfortable with will work as long as you do it correctly, of course. So that's going to give me x minus 96 is greater than or equal to, remember you got to flip that inequality when you divide by a negative. And then I'm going to add 96 to the other side. So that gives me 96 minus 8.65, which is 87.35. Okay. So what you're going to notice with our two results here is that this is always going to be an and. Okay, if you do it correctly in these types of problems, it's going to be an and situation. And an and is when these two things can be true at the same time. Okay. A number can be less than $104.65, but also greater than 87.35. So we can write it as what we call a compound inequality. That's where we have two inequality symbols. So we know that it is between these two values. And remember, x represents the personal goal. Okay, you could have used p or g or another value. But let's talk a little bit about what this means. This inequality here represents what he has to be between to keep the average within his 8.65 dollars within his goal. That's what he has to remain between. Okay, that's the context of the problem. Okay, so I'll talk a little bit through the context as well as we go through, because that's really important for these types of problems. So now that you have the general idea, let's go ahead and do some more. So the width of a license plate should be 6 inches. The manufacturing tolerance is within 0.07 inches. Okay, so if we take our width, okay, and we subtract 6 from it, okay, because let's say, for example, the width was like 7, okay, and we subtract 6 from it, that's going to give me 1. And that would not be less than or equal to 0.07. It would not fall within that necessary range, okay? So we take our width, we subtract 6, and we know that that amount has to be less than or equal to 0.07 in order to be acceptable by the manufacturer's tolerance, okay? So that's the reasoning behind why we have to set it up this way. Our width, when we subtract away the actual amount that it should be, that's going to be the manufacturing tolerance. And when they talk about manufacturing tolerance, they're saying that they'll accept if it's 0.07 more or less than 6 or anything in between that amount. Okay, but nothing more than that. That's why it's less than or equal to. So to solve this inequality, we do our positive and our negative version. So that's basically the maximum that it could be. And this is the minimum that it could be in order to be tolerated by the manufacturer. So remember, it's an and because these two things can be true at the same time. A value can be greater than 5.94 while still being less than 6.07. That's the difference between an and an or. So this is going to be between these two values. So the context is, in order for the width to be accepted by the manufacturer, it has to fall within these measurements in inches, okay? Camden enjoys surfing. During the winter, he caught several waves with an average height of 8.1 feet. All the waves he surfed were within 3.3 feet of his average, okay? So, if we take the height of the wave and we subtract away 8.1, that amount should be less than or equal to 3.3 in order for it to be within 3.3 feet of his average, okay? Now, you can go through and do the procedure like we did each time, okay? But you might see a pattern here. Essentially, one of these is going to be added and one of these is going to be subtracted from our value, okay? So if you see that pattern, you can go ahead and jump in to this step right here. If not, feel free to do it the longer way. Whatever is going to give you the correct answer is going to be the best way you should do it, okay? But what I'm saying is, we know that h is going to be between, I can take 8.1 minus 3.3, And that gives me 4.8. And then over here on this side, I can do 8.1 plus 3.3. So that's a little bit of a shortcut if you feel comfortable enough to use it. So what that essentially means is, in order for our average height to be within 3.3 feet of our average, we have to remain between 4.8 and 11.4 for all the wave heights. So that's how you do that. Zahara is practicing for band tryouts. To do her best, she spends an average of 56 minutes each day playing her flute. Each of her daily times, is within 14 minutes of her average. So if we take her playing time and we subtract away the average, that amount, if we want it to remain within 14 minutes of the average, has to be less than or equal to 14. If it's any more than that or any less than that, it's not going to fall within the average, okay? And we can kind of do the shortcut I was talking to you about. Just simply adding and subtracting 14 from 56. So if her playing time is between 42 and 70, she will remain within 14 minutes of her average. So it's a pretty simple concept. It's just a matter of really understanding the context and the reasoning of why we set it up the way we do. So that's it.